Um, so this is going to be like the highest level machine learning AI overview I can give you. So if it's too high, let me know. If there's still confusing stuff, let me know. But I hope this is like enough to get you started understanding what like machine learning and AI is. So of course, machine learning and AI is this. When you say I work with AI, they always think you're talking about robots or the Terminator. And this is still like a category of AI. So researchers or theorists talk about this as general AI. So that's robots, supercomputers, it's all like the sci-fi stuff. Most people have decided this is like not possible. Like it's not humanly possible, at least in the next 30 years, that we're gonna actually like have these things. But we still want to talk about AI in like a way that we do work with data. It looks like to someone who doesn't know what it is, it looks fancy, it looks like a robot. You can make money by selling it to people, like it's like snake oil salesmen. But the theorists and scientists who want to make like a living and feel good about it have called it narrow AI. So what narrow AI does is it's basically like it does one thing really, really, really well, right? So that could be a recommendation algorithm. That could be you can give a machine images of cats and dogs, and it figures out which ones are cats and figures out which ones are dogs, right? So like an example of that is this is horse to zebra. So this converts images of horses to images of zebras. If you were to try to give it flowers and convert flowers to zebras, it would fail miserably, right? So it does a very narrow thing very well. And this looks like magic to people, and they're like, cool, well now let's do that with humans. Like make a human look like a zebra. And it's like, that's not how it works. You could train it on a new set of data, and it might get there, but this particular library, which is called CycleGAN, is like tried a number of different things to convert A to B, and they're basically like, horses and zebras was our best demo. Everything else is like a little bit weirder and doesn't really work as well. So this is basically like to point out that like, and I'll also do a demo with some runway stuff to show you like a lot of AI and machine learning stuff sucks. It is not good. And I think like there's like this hype around the world that like, oh, like AI is gonna take over the world in 10 years. And it's like, if you look at what we have now, it's like not very good. So it's hard to extrapolate that to like 10 years out and be like, robots are gonna take over the world, right? Like there are definite places where like AI done well, but trained on bad data can do some really shitty stuff. And we'll talk a little bit about that, like places like surveillance data or like criminal behavior where they try to like guess whether you're going to be a criminal in the near future. Like they train on really shitty data, so they get really bad results. But people look at it and they're like, wow, it's amazing. It must be right? It's a computer. So again, the big thing to remember is like AI, like as it is today, is like it does one thing well, and that's it. So the thing to remember, and as you learn this stuff, is like, what's the one thing this thing is supposed to do, and how do I take that and apply it to my own work? And I'll talk about that probably more next week about models. But like the thing about each model, and this is, so again, models are basically like, what is the one thing it does well? Like that's the easiest way to think about it. You have to learn what the model was trained on and how it is meant to work, and then you either follow that or you break it. And when you follow it, you get like decent results. When you break it, you get really crazy stuff. Sometimes it's really cool, and sometimes it isn't. And you just have to sort of like find out what is meant to be there. So the 3 steps to any machine learning project are build, train, and test. This is sort of like the way that, this is like sort of the software engineering thinking side of how machine learning works. So build is create these architectures and these networks. So we're not going to do that in this class. This has all been done by like crazy, really smart computer scientists who release their code on GitHub, and we're just going to download it and we're going to use their architecture. There'll be some parameters or like variables we can tweak here and there, which are almost like sliders to like try to do different things. But for the most part, it's like, this is what you got. Can't really change it that much. The training is where we get into paper space. So in the case of like the horses to zebras, that was pre-trained on a bunch of images of horses and a bunch of images of zebras, and the machine figured out how to convert the two. So they trained that on probably 1,000 images of horses and 1,000 images of zebras. So this is what's called training. Most people don't do training. The reason I teach training in this class is because training is where the creativity stuff is. You could take someone else's model and like play with it, like take their training data and play with it a little bit, but you'll never get interesting results outside of what they've already created. So we'll talk more about training next week because that's also where your data sets come into play. But basically, training is where like the fun potential creativity options are. But testing is really important because testing is in data science world with data, it's like that's the test to make sure this whole thing works. But for us, this is where we make art. So the testing thing is like, we have an idea that if we train a bunch of stuff on some data, we're gonna get a cool result when we test it. Sometimes you get a cool result, sometimes you don't. Then you gotta go back and figure out, is it because I fucked up the training? Or is it because the way that the model was built was not intended to do what I meant it to do? And that's like one of those things where like, you never really know what you're getting yourself into. Like I've spent 10 days training something and I was like, I'm gonna get some really cool. And I test it and I'm like, this sucks. And I just lost 10 days, not like 10 man-hour days of my life, but like some money, some time, a little bit of effort, like that sort of thing. So it's like kind of hit or miss. Like you'll find out whether or not it works. More often than not, it'll work. You'll get some interesting results. The other thing is like you might get results you never expected, and that again is like a place where you're like, oh shit, this is even better than I expected. And I've got some examples of that where like my own work, I was like, oh, it's even better than I imagined it would be. So for you, like the big things to remember are like training and testing. And training is where you feed the machine a bunch of images. It does the thing it's supposed to be doing, trying to learn stuff, and then it comes back and then you try to test off of it. Any questions there? Okay, so I promised no math after this class, but this is the one math exercise you have to do. So these are 5 dots. I'm sure you did this in math class, but like, can you imagine drawing a line between all those dots to basically like give you the average between those? Yeah? It looks something like this, right? So this is the basic thing of how machine learning works. That's it. Like that's really it. Like it sounds like I'm like lying to you or like feeding you a line, but like that's really it. Now what happens here, what's different with machine learning, is instead of 5 points, you get a billion points. And instead of 2 dimensions, this is a 2D thing, imagine that's in 3 dimensions, and then you've got points in all those. And then actually imagine that's like in 1,000 dimensions, which is like our brain can't do, but that's basically what it is. So imagine that this is, let's see, what's a good way to imagine this? Imagine that these are colors. So let's say like this is, actually let's say it's this grayscale. So imagine this is black, imagine this is white. These are different images. And I'm trying to guess like, okay, like of these images, like the average color is like through here, right? So that means if I were to say, hey, create me a new image here, it would say, cool, it's probably gonna be grayish, right? So the way that machine learning thinks about stuff is they think about things called features. So grayscale could be a feature. If you think about a face, your eyes could be features, the colors of your eyes could be features. Am I smiling? Am I not smiling? Those are features. So when we think about features, those features become dimensions. So the reason that machine learning seems so crazy is because it's doing billions and billions of computations in a space, and like we as humans looking at a picture couldn't do it, but a machine can. So all it's taking is like it's doing this thing, and it's doing it like on a ton of data, right? So it's like what a machine is perfect for. Cool. So now I've shown you how to do machine learning. We're done, ready to go. We didn't get any laughs. Okay. I'll work on that. You guys ever seen the meme "How to Draw an Owl"? Oh, okay. All right, hold on. I'm actually gonna bring this up. This like joke doesn't work if you like are not aware of this. Oh, I just stopped recording, didn't I? Nope, I didn't. Okay. So I like, in my brain, like I thought this was really funny because I was doing this, but for machine learning. but like clearly didn't land as well. It's fine. I'll work on it. But basically, yeah, it's like it's so easy for me to say that like this is what we're doing, but like this is what we're doing. So like you do this, you do it a bunch of times, and like you get some really weird, wacky images. The truth is, sorry.
You're recording.
I think we are. Yeah, we're still recording. Yeah. So like what's happening here is actually like not even machine learning people know exactly what's going on here in some cases. So there's a thing called deep learning. Basically everything we're doing in this class is deep learning. And again, you're going to laugh when you find out what deep learning is. Deep learning is there are layers. That's really the only thing that we call deep learning. So the way this works is an image goes into the machine. So this is the network. When I talk about a network, this is basically what I'm talking about. And like the truth is, none of us have to know what any of this is in here. Really what we care about is what goes in and what comes out. So in this case, this is what's called a classifier. So in this case, an image of a dog goes in. The machine does all its magic, and it comes out and says, yep, that's a dog. Or if it were 0, it would be like, that's a cat, or not a dog. So when we talk about deep learning, we're talking about this. So what's going on in here? So when I talk about features, that's basically this. This is where the machine tries to figure out what features are there. So see sort of here, like this is a theoretical understanding of how layers work. The reason we call it deep is like literally we don't know. Like that's just all it means. It's like we might know what's going on in there, we might not. So at this level, it's like very pixel based, right? So this might be like what's the grayscale pixel of that image, or like what's the color pixel of that image. Then we start to like put some things together. So in this layer, it's sort of combining things. So it's saying, cool, so take a bunch of these pixels in the same area, and do I get a vertical line? Do I get a horizontal line? Like what's sort of there? Then like if you imagine like a smile, or like imagine a not smile, like I'm not smiling, I'm not frowning, right? That's almost like a straight line. So it's saying, okay, cool, well, like maybe that's a feature, right? So like a straight line is a feature. I don't know what that means, but a straight line is a feature versus a line that does like a curl. It's now taking all those edges and saying like, okay, well an eye is also like a curl up and a curl down and a dot in the middle. Now we're into like features. So now it's saying like, what are all the features that make up a dog? So you might get an ear, you might get a tail, you might get like brown color, fluffy color, like those sort of things. This is just to explain this, like it's not exactly what happens, but it's like close enough to a metaphor for us to sort of understand how it works. And then at the end it like sort of says like, okay, cool, that's what a dog looks like. And so the reason you need a ton of images is like one dog is only going to give you like enough information to like figure out that one picture again, right? Like I need to see a dog from the side, I need to see a dog from the front view, I need to see a dog where it's sitting weird, I need to see different types of dogs. So you have to feed this thing a ton of images in order for it to like understand what a generalized version of a dog looks like. And I also have to train it on what a bunch of cats look like so it knows what a dog doesn't look like. So this is where like you need a ton of images. And like most classifiers are like, this is what Google makes, right? They go through their Google image cache and they download 1 million images of a dog, 1 million images of cats, train it, and now we as like artists can use the classifier. Like we can say like, cool, that's a dog, that's a cat, pretty easy. So this is like, Google might train their own model, we just test on it. So that's basically, that's like machine learning in like the 20-minute version. Does anyone have questions? I'm sure you have questions. Does anyone have questions that like, well, does anyone have questions? Let's just start there.
So like, we as humans are not like defining what the features are that the machine is finding. It's just like the patterns that it recognizes in like
Yep.
bazillions of pictures.
Yeah, and it turns out that like, so machine learning and AI like comes from like, so half it comes from software engineering, right? The other half comes from like cognitive science, which is like, how do we think about, how do humans actually use our brains? And it turns out like, as we do more cognitive science, it turns out that our brains actually operate this way too. So we see features. So if we were to see an animal that we'd never seen before, we would try to classify it, right? If we saw an animal that kind of looked like a cat, we'd be like, that's a cat, right? Like, it's got a tail, it's got like a certain type of fur, It has ears that are pointy the same way I would expect a cat to look like. But it turns out it's a fox, right? Now our brains have to train how to change, like, what are the features of a fox that we look for? But what's funny is, like, when they build these models, they didn't build it with the intention of, like, we're going to replicate the human brain, right? They're just like, let's try to do these features in these layers and see what happens, because we know that's kind of how the brain works. This is Gene Kogan. He's like a really great, he runs a thing called Machine Learning for Artists. Covers a huge range of stuff that I will never cover. I got some links to his stuff here. This is a computer version of, or a visual version of how layers work. So these are actually the layers that an image is looking for. That doesn't make any sense to anyone, I'm sure, basically, like, you can imagine, like, this is looking for a bunch of horizontal lines. These are looking for certain colors at a certain angle. These are the things that it's looking for. And when he feeds that, what the machine is looking for, into his own face, this is what you get out of it. So in some cases you get, like, a pretty clear picture, and maybe this is looking at, like, grayscale-ish values. But then in other images you get, like, this just picks up his face. Or this picks up, like, this one's pretty great because it picks up just his facial features, right? It picks up his hairline, picks up his eyes, picks up his nose, picks up his mouth. So, like, this is what the machine is seeing in the best approximation we can. So if he were to train this on a bunch of faces and then train it on, like, I don't know, a water bottle, you would get very different layers here. And that's what the machine is learning. It's learning, hey, with all these layers, that's probably a face. Or when you get a water bottle, it says, hey, with all these layers, that's probably a water bottle. And you end up in weird places where, like, so I think there's been a model where, like, I'm trying to remember what it is, but, like, basically, like, another way, so you get some funny things where, like, let's say I'm holding a water bottle in the camera picture, right? What the model actually learns is your hand in this shape. Why? Because every image it saw was your hand holding a bottle in this shape. So, like, it might not learn what you think it's learning. Like, you might think, like, oh, it's learning the shape of a water bottle. Perfect. But what it might actually be learning is, like, every time you show me a water bottle, the background was brighter. Or every time you show me a water bottle, it's because your hand was in this shape. So it's a little bit of, like, this is where, like, that training comes into play, right? You train it and you test it, and you're like, why is it not, why if I do this to the photo, or to the screen, does it think this is a water bottle? Well, it's because it's about my hand, not the water bottle. So this is where you have to, like, iterate through training these things and find out, like, oh, I didn't train this well enough. Or it's only, like, I want to learn between Gene's face and a person without a beard's face. Like, then you just train on those two, and maybe you get enough. But then remember, it's narrow. It only learned between your face and a face with a beard. So if I want to train it on someone who has shaved half their face with a beard and, like, has long hair, like, it might not learn that, right? So again, remember, like, these things are as dumb as you make them, and how you train them determines how they test out. Any questions? Okay.
I guess one question I have, and maybe
Yeah.
you're gonna go into this, is, like, so, like, when you feed that image of the dog, like, you're telling it each time, like, hey, this is a dog, right?
So,
Like, that's
okay,
how you
yeah.
get to the, like, sort of, like, cha-ching, yes, you're right.
Yeah, so that's a great question. So there's two different types of models. One is where you do give it data, and another is where you don't tell it what to do, but it tries to figure out itself.
Okay.
And those work in different ways. So obviously, like, if I gave a model 1,000 pictures of a dog and 1,000 pictures of a sea turtle, and I said, hey, just go at it and tell me what you think these two are, it wouldn't say this is a dog or this is a sea turtle. It would say this is 1 and this is 2. And I know 2s generally always look like this and 1s always generally look like this. But I know they're different. But you could label all your data and say, like, hey, this is a dog, hey, this is a sea turtle, hey, this is a giraffe. And then it would, like, learn those labels. And then it would be able to spit back 1 is a dog, 2 is a sea turtle, 3 is a giraffe. But it doesn't actually know this is what a dog always looks like. Or, like, this is, you know, it's like based on the training data you gave me, this is the label you provided me. Yeah.
And then if you, like, gave it something else that wasn't one of those things, would it like try and put it in those buckets, or would it be like this is like something else?
It depends on how you build the model, but more or less it's going to try to figure out a category for it. Yeah, I mean it's generally like a classifier type of data. Like it's generally going to be like if you show a human's face to a cat or dog classifier, it's going to try to guess one or the other. But what it'll give you, this is getting more into classifier models, which like I won't really be working with today, like at all. But basically, it'll give a prediction score. So it won't give you like a 1 or a 0. It'll give you like I believe this is 75% like likely a dog. This is 25% likely a cat. So if you gave it a face, it might say, I'm 25% sure this is a dog, and I'm 25% sure it's a cat. It's like, it's probably neither, but I don't really have enough data to know.